pleasant and warm welcome to our first daily maths challenge. Today we're going to look at algebraic operations. I'm Teacher Holton. It is important before we start to appreciate what God's word is saying. And in Matthew 21:22 we read, and all things, not some things, all things whatsoever ye shall ask in prayer, believing ye shall receive. So we are trusting God that as you continue to pray for good success in your math exams, you're going to believe in God and you're going to not waver. And of course, you will receive it. Now we're going to look at 4 questions today. I've went ahead and write up the solutions for you. So we're going to go through the solutions for each question. And of course, that will complete our daily challenge when we have finished. So let's go straight into question number 1. Question number 1 is looking at a function f of x, right? So let's get our pens out. Looking at a function f of x. And we're gonna have to find a missing value. This value is k. So f of x is defined as 2x cubed plus x squared plus kx plus 15. And we are also told that f of x is equal to 2x minus 1. Here it is, 2x minus 1 multiplied by x plus 3 multiplied by x plus 5. So let us bring these two functions together. Now the first part of the solution is going to do exactly that. It's going to bring our f of x, which is really 2x minus 1 by x plus 3. The first thing we can do is multiply your term in the second bracket by the terms in the third bracket. And this is what we're going to get. X multiplied by x will give us x squared. X multiplied by 5 will give us 5x. 3 multiplied by x, 3x. And 3 by 5, 15. Nice. So what do we do next? We're going to go and isolate term in x, having simplified 5x plus 3x to give us 8x. So we want to isolate that term in x because we need to find the value of k, and the k is the coefficient of x, the number in front of x. So I've put a note here. Remember, this is an exam, a time exam. Time is of the essence. So there's no need to fully expand the entire expression since you're only required to find the term in x. So when we look at this line here, our term in x can be found by multiplying 2x by 15 and minus 1 by 8x. And let's do that. To find the term in x, we multiply, as we see here, 2x by 15 plus minus 1 by 8x. And of course, we will expand that bracket and we're going to simplify. Let's see what we get. 2x by 15 gives us 30x. And minus 1 by 8x gives us minus 8x. Simplified to be what? 22x. So therefore, remember, in the problem above, you were asked to find the value of k for the term in x. And that value of k will be 22. So let's go back to the top of the problem. And let's choose the correct answer now. So the question was, find the value of k if f of x is equal to 2x minus 1 by x plus 3 by x plus 5. Now I chose to multiply by the last pair of factors. Any pair of factors which you multiply by would have further simplify that expression, and which would of course make it easier for you to find the term in x, as I just showed you how to do it. So the answer would be D. Would you like me to go over that with you? Okay, let's run it again to make sure you understand. Let's do it again. Let's take out all these markers, I'm going to do a different approach, similar problems, you'll be able to follow it clearly. Right, so you work with me. Let's clear this. Right, so let's take it from the top now. That was my solution. Now let's take it from the top. So I'm given 2x minus 1 multiplied by x plus 3 multiplied by x plus 5. Now, this expression is equivalent to 2x cubed plus x squared plus kx plus 15. I am asked to find the term or the coefficient of x, which is the value for k. Find the value of k. Here it is. Now, this function here, which is on the right, this function on the right here, can be factorized to give the factors of the function shown on the left, right. Now, if you want to find the value of k, you need to appreciate that what is on the left is identically equal to what is on the right. Now, I chose to multiply or simplify, if you want to put it that way, these two factors. So let us try simplifying and working it with these two factors here. The reason I'm doing that is that it makes our solution much easier. So let's first multiply 2x by x, then 2x by 3. Too many lines there. Let's take out some. Let's go again. 2x multiplied by x, that will give me 2x squared. 2x multiplied by 3 will give me plus 6x. Minus 1 by x minus x. Minus 1 by plus 3 minus 3. Of course, I still have to multiply by x plus 5. And of course, that is identically equal to 2x cubed plus x squared plus kx plus 15. Term in bracket simplifies to 2x squared plus 5x minus 3 by x plus 5. And of course, that is identically equal to 2x cubed plus x squared plus kx plus 15. So I need to find the value of k. Here it is, the value of k. and that is the coefficient or number in front of the letter x. So I need to find the term in x. So I need not expand the entire product 2x squared plus 5x by x plus 5. Now to find that term in x, I can multiply 5x by plus 5, and I'm adding that to the product of minus 3 by x. Let's do that. So 5x multiplied by plus 5, and I'm adding that to the product of minus 3 by x. And that will be identically equal to my term in x, which is kx. So I need not focus on any term in x cubed, x squared, even the constant, because I was not asked about that. So let's simplify. So 5x by 5 gives me 25x. And I'm now minus 3 by x is minus 3x. Plus 1 is understood here. Minus 3x multiplied by a positive 1 will give me minus 3x. And that is identically equal to kx. This comes down to 22x equals to kx. So therefore k is equal to 22. Now I just did it this way, where I multiply the first two factors to show you that unlike the working here where I chose to multiply the last two factors, I will still get the same answer for k. Okay, so let's go ahead to question number 2. Right, so question number 2 is testing our ability to simplify two algebraic fractions, 2 over x minus 5 and 3 over x squared minus 25. Now, part of the solution will involve factorizing x squared minus 25. Now, x squared minus 25 is an example of the difference of two squares. So I'm just giving you the general expression, and this is the same thing as x plus y by x minus y, or you can write it the other way around, x minus y by x plus y. Now, how do you get your x and y? You must express each term as a square. Now, x is already squared, but 25 isn't, so it must be expressed as 5 squared. Now, when you compare your third line with the general expression, you would notice, well, x is your x, but y is not 25, y is 5. So therefore, x squared minus 5 squared is the same as x minus 5 by x plus 5. Of course, it doesn't matter which factor you write first, x plus 5 by x minus 5. So once we can get over that hurdle, and I'm going to put what we just did here in terms of the factorization, that is the factorization involving the difference of two squares. So this is one square, take away another square. So it's difference of two squares. One square, take away another square, the difference of two squares. So take note of that. Right, so let's go to the actual solution of the problem. We need to pick the right answer from among the choices here. Now, if we scroll down a bit, in fact, let's leave it there so we can compare quickly. So I can rewrite in the solution x squared minus 25 as x minus 5 by x plus 5. I just showed you how I got it here. And this is where I now find my LCM. My LCM will be x minus 5 by x plus 5. And of course, I can go ahead and simplify. I would say, let me write it over for you. So the sum becomes 2 over x minus 5 minus 3 over x minus 5 by x plus 5. I realize reading out a solution or even trying to explain a written solution may not be as effective as you see me actually working it out for you. So the LCM here is x minus 5 by x plus 5. So as you would normally work fraction, you would divide the LCM by the first denominator. So if you do that, the x minus 5 will cancel out with this x minus 5. So you're left with x plus 5 multiplied by 2. And then you are subtracting your 3. Of course, this LCM divided by x minus 5 by x plus 1 gives you 1. So it's 1 by 3. So let's simplify now. Expanding our brackets. 2x plus 10 minus 3 all over x minus 5 by x plus 5. Okay, and of course our numerator further simplifies to 2x plus 7, and we can rewrite the denominator originally as it was as x squared minus 25, because we did say up here x squared minus 25 is the same as x minus 5 by x plus 5. Added to that, your answer, the denominator in each of these answers is written as x squared minus 25. So when we compare, the correct answer will be C. Okay, let's proceed to question number 3. Question number 3 is a very interesting question, and it tests your understanding mainly of what is called the factor theorem. So the problem says, given f of x, which of the following is a factor of f of x? And they give us 4 possible factors. One, of course, will be the correct one. Now, I've restated the factor theorem here for you. If x minus a is a factor of f of x, then f of a is equal to 0. So you substitute the value of a. Note you do not substitute minus a. You don't take the sign, you choose the opposite sign. So if it's negative, if it's x minus a, you substitute f of plus a. If the factor was x plus a, you would substitute f of minus a. You'll see more of that later on in the working. So let's take the first factor. Now, if when you substitute based on what the factor theorem is saying, you get what is called a remainder of 0, then x minus a is a factor of f of x. Now, the remainder theorem generally states that rule, but what it says is if f of x is divided by any factor x minus a, the remainder is f of a. So you just substitute your value here, remembering that you do not include the same sign but the opposite sign when you are substituting. So if it's minus a, you substitute f of plus a. And if it's plus a, you substitute f of minus a. Now, if your remainder, and this is important, if the remainder is not 0, some value other than 0, then your factor, sorry, not your factor, then your expression is not a factor. And if it is 0, as seen by the factor theorem, then your expression will be a factor. Now, what I've done, I have done the working for all of these possible factors here, and we'll see which one is in fact the factor for f of x. Now let's look closely at the working, so you'll be able to follow what was done. So notice what I've done. This is a multiple choice. The best way is to look at each of these possible factors. So I'm going to put a little question mark here, possible factors. And we're going to substitute your corresponding values into f of x. So if your first factor is x minus 1, what you sign, it's minus 1. You're going to now substitute f of plus 1 into the expression where you see x, you're going to put plus 1. I've done it here for you. So it becomes 2 by 1 cube plus 1 square minus 3 by 1 minus 14. Be careful when you're expanding. 1 cube is 1 by 1 by 1, which is 1, 2s are 2. 1 square is 1 plus 1 minus 3 by 1 is minus 3 minus 14. 2 plus 1 is 3 minus 3 is 0 minus 14 is minus 14. Now note, your remainder here is not 0. Let's go back to the factor theorem. If f of x is divided by x minus a, in this case it's my x minus 1, the remainder is f of a, right? So in this case, f of 1 gives us a remainder of minus 14. If the remainder is not 0, here it is not 0, it's minus 14, then x minus 1 is not a factor of f of x. Now go back to the question. The question says, which of the following is a factor? So we can comment or conclude by saying x minus 1 is not a factor of f of x. Now I've structure the problem in such a way that we're going to practice with example number 2, which is your factor x, possible factor x plus 2. Again, watch how we substitute f of minus 2. Take your time with the expansion. Minus 2 cube is minus 2. Multiply by minus 2. Multiply by minus 2, giving us minus 8. So this is 2 by minus 8, giving us minus 16. Minus 2 square is plus 4. Minus 3 by minus 2 is plus 6. Minus 14. So let's see if I have added correctly. 6 and 4 is 10. Minus 16 plus 10 is minus 6. Minus 14 is minus 20. Again, your remainder here is not 0. So we can conclude that x plus 2 is not a factor of f of x. In my third example, your possible factor, again, is written as x plus 1. Let's substitute. Notice what's happening here. You put f of minus 1, the opposite of the sign here. And of course, we simplify. 2 by minus 1 cube is minus 2. Minus 1 square is plus 1. Minus 3 by minus 1 is plus 3 minus 14. Again, giving me a value as the remainder, which is not 0. So I can conclude that x plus 1 is not a factor of f of x. Now, of course, by a process of elimination, one of them must be a factor. And so, answer must be D. Let's check it. So we have x minus 2. We substitute f of 2. 2 cube gives me 8. 2s are 16. 2 square gives me 4. 16 and 4, 20. Minus 6 is 14. Minus 14 is 0. So once you get a remainder of 0, the factor theorem says that x minus 2 must be a factor of f of x. So we will go with answer D. So I hope this aspect of remainder and factor theorem is a bit clearer. And finally, our last sum. Let's go up a bit. Okay, I'm moving a bit too quickly there, a bit anxious to finish. So it would seem, there it is. We need to factorize this. The expression 2x minus z minus 3y minus xy plus 6z. Let's do that from scratch. You will examine each term and you look at two of the terms at a time and you attempt to factorize each pair. Now, if, as we examine this first pair here, there is no common factor, then you can rearrange the terms so that you actually get a common factor which can be factored out. So let's put it as 2xz minus xy, and we have minus 3y plus 6z. Now let's change ink on you right there so we can highlight something. We're going to factorize these two, then we're going to factorize these two. This process is called factorization by grouping. This only works when you have four terms. And we do have four terms here. Factorization by grouping. So the common factor here is x. No, is it? Well, yeah, x. Come on, let's take out x. Yep. And we left with 2z minus y. And let's see what's happening here. Let's attempt to take out minus 3. And we're left with y minus 2z. Now let's double check that. When you expand your brackets, you should get back what you have above here. Minus 3 by y is minus 3y. Minus 3 by minus 2z is plus 6z. Notice how your sign changes because you have factored out a negative quantity here. That is minus 3. Now, we did say factorization by grouping works when you have four terms. What are these four terms? Not four letters, they're four terms. A term is separated by a plus and or a minus sign. So let's see how many terms are separated. Here are your signs. Terms are separated by plus and or minus sign. So once you bear that in mind, you have 1, 2, 3, 4 terms here. Now, how do you know you're on the right track with factorization by grouping? When you factorize initially, the terms in brackets must be arranged in the same way. Or another way, the factors in brackets must be written the same. Now in this case, notice you have 2z minus y. 2z is written first and it's positive. 2z minus y, y is negative, but the opposite is here. It's positive y and a minus 2z here. So therefore, we need to rearrange this in terms of how we factorize initially so that our terms in brackets, both pair of brackets, or the factors are identical. So if taking out minus 3 did not work, we need to consider factoring out plus 3. So if we take out plus 3, and of course the original expression we are looking at is up here. So if you take out plus 3, you are left with minus y, because plus 3 by minus y gives you minus 3y. And if you take out plus 3, you are left with plus 2z. Now, when you take a closer look and really convince yourself that the factors in both pair of brackets are identical. So you have plus 2z, you got a plus 2z. We can even write that first here. And you got a minus y, you can even write that after there. So it's identical. So the last stage, let's highlight that now. You further factorize. Once your factors are identical, you can factor that out. 2y, 2z, sorry, minus y. And what you're left with your x. Note we are also taking the sign with the 3 plus 3. That goes in the next pair of brackets, and that'll be your second factor. So let's see if we have an answer resembling this. Remember, it's multiplication, so it doesn't matter which factor is written first. 2z minus y by x plus 3. 2z minus y by x plus 3. Here it is. So let's quickly go over the steps, and we're going to look at the final solution, and just to re-emphasize how you actually factorize by grouping. So factorization by grouping works when you got 4 terms. Now, we did have 4 terms here. The only thing is, in the original problem up here, we had to rearrange these 4 terms so that we can actually begin the factorization process. So we did write minus xy, because notice once you do that, you can actually identify your x, which is a common factor in these 2 terms. We factor out that x, we are left with 2z minus y. If x goes, you're left with 2z minus y. That's what we have here. Now, at first glance, it is instinctive to factor out minus 3. And that's what we did here. But if you take out minus 3, you're left with y. Of course, you must change this to minus, because minus by minus gives you back the plus. But a problem arose. If you have to factorize by grouping, your 2 factors must be identical. It was not the case here. So then, the best way to take any kind of action now is to change our sign. If we factor out minus 3, we will change it now to what? Plus 3. And it always works, as we saw here. Now, don't get confused at this stage. Even if you have minus y written in front of plus 2z, that minus y plus 2z is identical, the same thing as 2z minus y. The only difference is your term in y is written before your term in z. So we rearrange that, we cure that problem right here in the second pair of brackets. We decided to put the 2z first minus y. Now, quick note, a nice way to check to make sure that everything is in order is to make sure that your terms in each pair of brackets are identical. So those factors will be the same, which you can now further factor out, and you can do that by simply putting a line through both of them, and you further factor out once it is only written 2z minus y, and what remains, what you're left with, is the x plus 3 that goes in the second pair of brackets here. And of course, we search for our answer. Right, so what I'm going to do, with your help, we're going to do over this problem, and let's see if I can go up a little bit slower just now. Uh-oh. It's keep going a little too fast up there. All right, let's try it just now. Okay, so I got it here. I thought I got it. I thought I got it just now. Right, I got it here. So what I would have done, notice I would rearrange. Let me see if I can go up a bit. Hold on. I want you to compare what was done before just now. When I work this sum just now there, are you seeing that? Watch what happened. Right. Now let me take out, let's use a different color marker here so you could really follow what's happening. Let's use a colorful marker here. The problem was 2xz. No, I don't think that's working, too colorful. Right, the problem was 2xz minus 3y minus xy plus 6z. Now, if you attempt to factorize these two terms, there is no factor, no common letter, no number that we can factor out. Now, in the first problem, I had rearranged and I had written 2xz minus xy. In this solution, you can bring your plus 6z close to the 2xz, and in doing so, are you seeing how you can factor out z as well as 2 can go into this and 2 can go into this, and that's what I did here. I've decided to factor out 2z. So if I take out 2z, I'm left with x plus 3. 3 by 2 gives me 6, of course, and I'm having here my z, 6z. So this part is correct. Minus 3y minus xy. If I take out minus y, I'm left with 3 minus y by plus 3 is minus 3y. Notice my change in sign, minus y by plus x gives me minus xy or yx. So examine your brackets closely. Let's write it again. 2z multiplied by x plus 3 minus y by 3 plus x. Are these two factors identical? The answer is yes. X plus 3 is identically equal to or the same as 3 plus x. So we can now factor out one of these. Here it is, x plus y, not x plus y, x plus 3. All right. It doesn't matter if it's written first. And what I'm left with is 2z minus y. So I can now look for my answer up there, which is answer C. So that will bring us to the end of this session. That's the end of our challenge for the first day. Algebraic operations we looked at. And remember what the word of God said. It says that whatever you ask in prayer, once you believe, you will receive. And I'm agreeing with you in prayer that you are up for the challenge and you will be successful in your hard math exams by the grace of God. If you want to get more daily challenge, you can visit our YouTube channel, The Math Ministry, or you can visit our website at www.maths123.org. Thank you so much for taking the time to view, and may God continue to bless you and your family. Take care.